Hello students, this is Professor Prashant More recording live for Vidyanti.com. We are going to have a complete CBSE grade 10 math revision. Hopefully we will be able to complete that under 2 hours. So without wasting much time, this is my credentials. These are my credentials. Please have a look at it. Timestamp for chapters. In case if you want to skip some chapters, you can do that. I will provide that in description so that you can directly go to a specific chapter. We are going to cover all 12 chapters in one single shot. As usual, like, comment, subscribe and share this video to maximum exposure. And a free PDF in the form of cheat sheet will be provided. I will provide a link in the description, so please feel free to download. So let's begin. Our first chapter is going to be real numbers. Let's have a quick recap of the number set. When we started counting numbers, we started counting from 1, and this set is referred as natural numbers, which is used for counting. So 1, 2, 3, 4 will be extending up to infinity will be natural numbers. Then soon we needed a provision to indicate that absence of something, lack of something. So we added 0 and then it became whole numbers. Negative numbers were soon added because we wanted to go opposite side of the reference, such as underground, 3 feet. Or occasionally we owed money. So to indicate that, negative numbers were introduced. Integer set is infinite in both directions, and if you include in integers fractions, then this will be in the form of p by q. So integers plus fractions collectively will be called as rational numbers. And then we have irrational numbers such as root 2, pi, e. These are non-recurring, non-terminating decimals. Rational numbers and irrational numbers together will be real numbers, and that's what this chapter is all about. Later on we'll study imaginary numbers, which is square root of -1 is defined as I. Numbers containing this I, imaginary number, will be complex numbers. So for the time being we don't have complex numbers, we have only up to real numbers. But this is a spectrum of sets what we are going to describe up to real numbers in this chapter. Now this chapter also talks about prime numbers. Prime numbers are those numbers which are divisible only by 1 and that number itself. Please note that number 1 is neither prime nor composite. Prime numbers actually start from 2. Prime numbers are only integers. There is no such thing called fractional prime number, and you can have infinite prime numbers starting from 2. So a sample set will be 2, 3, 5, 7, 11 and 13. Prime numbers are important because we have fundamental theorem of arithmetic described in this chapter. Every number can be expressed as a unique factorization of prime numbers. So the only order will be here and there, but the prime factors and their powers will be same. So for that purpose, and to calculate highest common factor HCF and least common multiple LCM, these prime numbers will be used. So with this one, now we will talk about HCF, which stands for highest common factor. Highest common factor is the maximum number which is divisible by the given numbers, or the given numbers are actually divisible by that number, and that's the maximum number. In the textbook we have been given only 2 numbers questions, but occasionally you can come across like 3 numbers or 4 numbers also. So let's take a quick example. HCF of 18 and 20 is 2, because 2 is the maximum number. We cannot have any number greater than 2 by which we can divide 18 as well as 20. So that will be highest common factor. And least common multiple, denoted by LCM, will be of 18 and 20, same numbers, will be 180. So this is the least number such that both given numbers 18 and 20 are divisible, are able to divide that 180 number. So this was just an example. How to find out HCF and LCM? Well, we have to do, there is a theorem coming up, we'll see this in a while. 18 can be factorized with the help of prime numbers, as you have to divide by 2, remains 9, then divide by 3, remains 3. Again, repeat that process until you get 1. And if you have 20, let's repeat that process. 20 is divisible by 2, we get 10, 10 divisible by 2, we get 5, and in the end 5 divided by 5 is 1. Please note that this requires basic understanding of divisibility. Now here I have taken very small numbers 18 and 20. These are 2-digit numbers, but occasionally if you have 3-digit numbers, we are going to solve one quick problem immediately after this slide. So you need to know which number is divisible by 2. Well, when we talk about even numbers, these are the numbers ending with 2, 4, 6, 8, 0. Odd numbers are 1, 3, 5, 7, 9, ending with that. Even numbers are divisible by 2, odd numbers are not. So if the digit is ending with 2, 4, 6, 8, 0, the number is divisible by 3. What about divisibility by 3? If the sum of digits is divisible by 3, then that number is divisible by 3. If the number is ending with 0 or 5, the number is divisible by 5, and so on. So you need to have some basic understanding of divisibility test, and I will talk about like basic things such as 2, 3, 5, 7 and maybe 11. These are the prime numbers we are supposed to divide for the prime factorization. So now how we let's go back to our original topic. HCF and LCM can be calculated by writing down their prime factorizations, and whatever is the common factor, let's say 2 and 2, so that will be taken only once. That will be your HCF. This will be your highest common factor. In order to calculate LCM, we'll take the non-common factor and then multiply them with common factor only once. So here 3 times 3 is 9, and this is 10, so 9 times 10 is 90, but then this 2 and 2 will be taken only once because it's common. So 90 times 2 will be 180, and that will be your LCM. There is a theorem in the textbook which says that LCM times HCF will be product of the two numbers. So that means least common multiple and HCF, highest common factor, their multiplication is exactly same, identical as the multiplication of the given two numbers for which HCF and LCM is calculated. We are going to see a quick problem based on that. This is directly taken from the textbook. I have a lot of videos already put on the YouTube. Please refer to see more videos. I'm going to cover only one question from each chapter. Given that HCF is equal to of these two numbers 306 and 657 equal to 9, so we are supposed to find out LCM. Now we have this interesting equation, LCM times HCF equal to product of two numbers. So that means there are 4 things involved, the original two numbers and LCM times HCF. Out of these 4, if you know any 3, then the 4th can be found out. So they can twist the question. Here they have given the 2 original numbers, so right hand side is completely defined, but out of LCM and HCF they have given only HCF, so LCM is supposed to be found out. So what are the possible ways they can ask this question? Well, number 1, they can give the original numbers and one of these 2 things are missing, like what we have been seeing in this question. Or the second possibility is they can give LCM and HCF and one of the numbers can be missing. They can very well ask that one. So as long as 3 out of 4 things are known out of this equation, you should not have any problem. So let's just a matter of substitution. LCM times 9 is equal to 306 times 657, times 9 will be taken on the other side. 306 is divisible by 9. How do I know? Because 306, the sum of the digits is 3 plus 0 plus 6 is 9. 9 itself is divisible by 9. So that means this 306, the original number, is divisible by 9. This is what I exactly meant by divisibility test. You should know the divisibility test for 2, 3, 5, 7 and maybe 11. That's the max I will go. And it's nice to know, well, 10, there is nothing spectacular to remember. If the end digit is 0, it is divisible by 10. And 5 also, if the end digit is 5 or 0, it is divisible by 5. So I'm going to divide this 306 by 9, and that would come out to be 34. Now I will multiply 34 by 657. This will give you 22,338, and that will be your final answer. Now, in the second chapter, we are going to talk about polynomials. Polynomials are things which involve multiple terms. The word poly means many, polynomials means many terms. Here we are talking about like some formula, basic expansions for squares and cubes. So let's have a quick revision. A plus b square bracket square equal to first term square twice of their product and last term square. A minus b square is equal to same thing, except the middle term twice ab is now negative. If you have once positive, once negative, once sum, once minus subtraction, then it will be a square minus b square. So these are quite handy if you are adding or multiplying things of polynomials. You should remember some interesting things about cubes also. A plus b the whole bracket cube is a cube plus b cube. Now 3a square b and 3ab square. If you have a minus b cube, then basically you will have the same terms, except the fourth and the second term will be negative. Now in this chapter they will say many times quadratic polynomial. Well, if they say linear, that means maximum power is 1. Linear they call it because it represents a straight line. That will be covered in chapter 3. Quadratic will be again covered in chapter 4. So we will have just understanding of basic terminology. If they say linear polynomial, that means maximum power is just 1. So we will have x. We will not have x square, x cube and higher power. If they say quadratic polynomial, means maximum power will be 2. So it will be in the form of ax square plus bx plus c equal to 0. A, b, c are coefficients. They will be just numbers, and x is a variable here. Maximum power of x is 2. So you will have x square term. You cannot have higher than that, which is x cube and so on. So this will be what they mean by quadratic polynomial. Now let's assume that it has 2 roots. Well, quadratic polynomial, because its highest power is 2, it will have at the most 2 answers. A cubic polynomial, which is the highest power equal to 3, will have at the most 3 roots. So let's assume that alpha and beta are the 2 roots of this polynomial, quadratic polynomial. Then the formula says that sum, addition of these 2 roots, which is alpha plus beta, will be given as minus b upon a. So there is another formula called product of roots, which is alpha beta, that will be c upon a. Remember, a is the coefficient of x square, b is the coefficient of x, and c is the constant coefficient. So if you happen to know a, b and c, even before you actually calculate the individual roots, remember these formulas, they may not give directly individual answers. They are giving you addition and multiplication of the answers. So sometimes that is useful because we know certain things about certain characteristics about those answers, and this formula can be directly used. So such formula exists for cubic also. It is mentioned in the textbook. However, problems will be kind of rare. For the sake of completeness, I have just mentioned there. Cubic polynomial maximum power is 3, so we will have x cube term is the highest power. You will not have anything beyond that, such that x raised to 4 will be absent. Now it will have 4 coefficients a, b, c, d and equal to 0. Now sum of roots, because it's a cubic polynomial, it will have 3 roots, alpha, beta and gamma. So their sum will be minus b upon a. The sum of any 2 roots, alpha, beta, beta, gamma, alpha, gamma, will be c upon a, and product of the roots, which is the multiplication of all 3 roots taken together, that would be minus b upon a. So these are the formula mentioned in the NCERT book. They can very well ask you to construct a polynomial given the 2 roots, or they can ask you to construct a polynomials given the sum and the product of the roots. So such questions can be expected. Again, a lot of videos are already included in my channel. Please take a moment to see them. I have almost solved nowadays plenty of homework problems. Complete video solution is provided on my channel, so please have a look at it. Let's take a conceptual quick question for understanding purpose. In this one, this is also from the standard textbook. They have been given us like various graphs, and they are asking how many zeros it has. First of all, there is a complete 2.2 section which is talking about the zeros and the understanding and meaning and all those things. Zero of a polynomial means that value of x for which the entire expression, the polynomial expression, becomes 0. So if you plot a graph, visually it can be identified very easily. If you plot a graph, if the graph cuts the x-axis, because remember the value has to be 0. So if the graph cuts x-axis, not y-axis, if the graph cuts x-axis, or if it is barely tangent also, that has to be considered. If the graph cuts x-axis, that is your value of 0. Unfortunately, this line is a flat parallel line parallel to x-axis, so there is no chance of, no matter how much you extend it in either direction, it will never ever intersect or cross or even touch x-axis. So that's why we have answer no zeros. This particular equation, which is represented by the straight line, will never have any zero simply because this line is parallel. If this line is inclined a little bit, having slope, yes, eventually we will extend it and somewhere we will get one root, but this line absolutely no. It doesn't have to be straight line, they can give you curve. For example, this curve is now intersecting the x-axis at one point, so it has 1 0. This is intersecting 3 times, it will have 3 zeros. This again intersecting only twice, so 2 zeros. This will be 4 zeros, and in the last one, well, it is intersecting once, but then 2 more times it is barely touching, and x-axis is tangent, that has to be also considered. So this particular graph has 3 0. So this polynomial, which is represented by this particular graph, will have 3 zeros. These are the 3 distinct values of x. If we substitute them in the original polynomial, this will become, expression will become automatically 0. Now, as long as chapter 3 is considered pair of equation in 2 variables, well, we have 3 different methods. One is graphical method, which involves like graph paper and actual plotting of the equations. Second method is substitution method, and the third one is elimination method. Let's see them quickly one by one. In graphical method, as the name suggests, you will take the straight line and you will plot a graph. So basic understanding of how we plot a graph has to be there. You need to have basic comfortable level with the graph paper, how to select scale, how to plot x-axis, y-axis, where is the origin, how to show different coordinates, where the coordinates are positive, negative, and those things you are supposed to know. We have done these things in the 9th grade. If not, you still have some time, basic understanding. There are some videos in my channel for grade 9 also, you can have a look at it. Let's assume that in graphical method you have been given 2 equations. So what exactly you are supposed to do? Take a graph paper and plot the graph of 2 straight lines. Now, how will you plot the graph? Well, create sample points. We are going to solve one question immediately after this one, so this point will be clear. Wherever these 2 lines intersect, that is your answer. So the graph will look like this one, assuming that these 2 are not parallel lines. Then this point of intersection, get the coordinates, and that's your answer. So x coordinate is your x value, y coordinate is your y value. We'll solve a quick problem based on this one immediately after this slide, so please stay tuned. Substitution method, we are supposed to express one variable. Remember, we have 2 unknowns and 2 variables. Remember, this is pair, means 2 equations in 2 variables. So you have 2 equations and 2 variables, 2 unknowns. So we are supposed to take the first equation, express one variable into another, and substitute that in the second equation. Cancellation will take place and you will get the final answer. We can see elimination method. Well, we are supposed to kill or get rid of one variable. So somehow by multiplication, you can multiply one polynomial or both polynomials by a constant. Try to make the coefficients same. If the coefficients are same, including sign, then you subtract them. If the coefficients are same with a different sign, you add them, and somehow try to get rid of them. This is the method of elimination. Now, there is one more thing here. They are talking about types of solution. Let's assume that you have been given 2 equations of 2 linear equations representing a straight line. Now, what kind of solution they provide? What is the nature of the answers when we try to solve them or simplify them? There are 2 major scenarios. So one is the ratio a1 upon a2 is not equal to b1 upon b2. Well, then you get like this kind of scenario. You will get only one solution because the 2 lines will be intersecting. And graphically, I can show a scenario which is very similar to this one. You get 2 distinct lines, they cross over at some location, you get one nice answer, and this is like the best case that can ever happen to you in case of solving 2 linear equations. Well, let's see the other possibility. What if this a1 by a2 and b1 by b2 is identical? Well, then we have further two sub situations. If this equal, if it is not matching with C1 by C2, remember C1 and C2 is something which we have not considered so far. If this equal relation, if it is not matching with the C1 by C2, then we have one scenario, sub scenario, and then if this is matching with C1 and C2, then we will get second sub scenario. In the first one, we don't get a solution because you have parallel lines graphically, because A1, A2 and B1, B2, they kind of define the slope. The ratio is defined by slope, and C1 by C2, their relative separation or dislocation. So basically you are getting same slope line, however this line is dislocated, and because these are two parallel lines, they will never meet, and since they never meet, there is no question of intersection, there is no question of solution. So you have parallel lines, the situation is okay, but you don't have any solution because these two lines never meet. As opposed to that, if you have this kind of situation, that means is the same equation just multiplied and given to you. You think that you have two solutions, but in reality you have only one solution and just manipulated. The same form of the equation is given to you. So you get a second line, but that second line is not really different. So you get an overlapping line. So these two lines are exactly identical. They are at the same location again. So they can, you can say that they intersect forever, and you get like infinite number of solutions, because simply here I have shown one line, but actually there are two lines. Second line is on top of the first line, so you can get coincident line, and hence you get infinite solution. So any point you take, it's going to be on both lines anyway. So you get, that's the reason you get infinite number of solutions. So these are the scenarios for pair of equation with two variables. Let's take a quick question from the textbook itself, 3.7. We have been given two equations, and we are supposed to create a triangle, shade them, and get the 2 points which are intersecting with the x-axis. Well, these are linear equations, so remember any 2 points are sufficient to plot a straight line. I will take the first equation, try to express that one variable into another, so that I will be able to create a table, and the table will be a pair of x and y coordinates which belong to that straight line. Again, there are infinite points on the straight line. You can have as many points as you want. Minimum 2 number of points are sufficient. Remember, you cannot plot a line with the help of just 1 point. That would be impossible. You require minimum 2 points. So take different values of x and get different values of y by using this equation. You have full freedom of taking whatever values. I go for normally 0 and 1 because these are simplest value. If you substitute 0, y will be 0 plus 1 is 1, and if you substitute x equal to 1, then y will be 2. So that means 0, 1 is one of the points on the straight line. 1, 2 is also a point on the straight line. Now some people will take 3 points, which is actually better, because like occasionally if you make a mistake in the calculation of the coordinates, then the third point will indicate you that really quickly, because the 3 points are supposed to be collinear. In the exam you find that, oh, they are not on the straight line. That means go back and check whatever calculations you have done. You might have done a simple mistake, fix that, and then the 3 points will come out to be in a single straight line, hence collinear. So 3 points are actually better. It depends upon like how much time you have during the exam. So I have got like 2 points which are bare minimum sufficient to plot one straight line. I will repeat this process for the second equation. In second equation, I will take it and try to express one variable in terms of another. Y is equal to 6 minus 1.5x. Now I will make a similar table, get different values of x, and calculate compute the value of y by plugging in the value of x in this equation. So my go-to value, simple value is 0. So 6 minus 0 is 6, and let's take another value here because it is 1.5. I have not taken 1 because that would create fraction. I will have some difficulty plotting the point on the graph paper. I have taken even value, so that 1.5 times 2 will become 3, 6 minus 3 will become 3. So I have now 2 points, 0, 6 and 2, 3. Now, as I said, you should have basic comfort level on the related to graph paper. You should be able to plot x and y axis, but remember how many squares you have. Now I have taken this with the help of software. I have specific number of grid lines or squares which I can manipulate but the graph paper which we have in real life will come with like predetermined specific number of squares. So you should be able to select a proper scale such that these points are reasonably within the paper. Remember, the points should not go beyond the paper. At the same time, the graph should not look like a really tiny fraction. So try to manipulate the scale in such a way that the points look really nice, well spaced, and occupy a fair share of the paper area itself. X-axis is horizontal, which is positive on the right side, negative on the left side. Y-axis is positive upwards, negative downwards. Their intersection point is origin. 0, 0 starts from here. 0, 1, that means you don't have to move anything along x-axis, but you have to move 1 along y-axis. So 0, 1 will be here along the y-axis. Quick tip, all the points on the y-axis will have x coordinate 0, and vice versa. All the points on x-axis will have y coordinate 0. Since origin lies on x and y both axes, the origin will have both coordinates, which is 0, 0. So when you see 0, 1, immediately you should figure it out that this is point belonging to y-axis, and 1 represents how far it is that from origin. So it is 1 unit along the positive y-axis, which is upwards. Now we can plot 1, 2, which is 1 unit along x-axis, 2 units along y-axis. Try to get these values as non-fractional as possible. Integer values will be preferred. If you occasionally get the negative value, make sure that you have sufficient space towards the left or sufficient space towards the down, because now your x or y or both coordinates are negative, and you need some space towards the left of the axis, towards the down side of that axis. So this is like these are the 2 points belonging to the first line. Now I will draw a straight line passing through them. Now this is the plot of one of the straight line. Now I will do the same thing. I will plot 0, 6, which is again along y-axis, 6 units towards the positive y-axis, which is vertically upwards, and 2, 3 will be here. I will draw the second line. Now, luckily, the point of intersection was one of the points. I didn't specifically choose that. It come out to be, I was just lucky in this case. This point may not be directly known. So whatever is the point of intersection, count how many squares you have along x-axis, count how many squares you have y-axis. So in this case, this is 2 units along x-axis, 3 units along y-axis. So our answer is 2, 3. So first coordinate is always x, second coordinate is y. So that means if you try to solve these equations, their solution is unique, number 1, because we have seen the 3 cases in the previous slide, and answer for x is 2, answer for y is 3. Now, in this question they have asked something different. Shade the triangular region and find where they actually intersect x-axis. As you can see, this line, this is the shaded region. This is -1, 0 intersects right here, and then we have 4, 0. So these are the answer, and this is the shaded region. So this basically illustrates a couple of things. Number 1, how to plot a graph, which is kind of revision of 9th grade mathematics, but most importantly how to solve 2 equations with the help of graphical method. You can use method of elimination or method of substitution, and that should give the same answer. If you want to cross check, that's fine. Quick suggestion, once you get the answer 2, 3, remember x is 2, y is 3, try to plug in back to the original equation just to make sure that you have got the correct answer. Remember, in the exam, such questions where you can verify the answer really quickly right within the exam hall should be preferred. That way, that should give you peace of mind that you have solved everything correct. That will boost your confidence for subsequent papers too. So here we got like x equal to 2, y equal to 3. Let's plug in back to the original equation. 2 minus 3 is -1 plus 1 equal to 0. Yes, this equation is satisfied. Let's try to plug in again x equal to 2, y equal to 3 in this equation. 3 times 2, which is 6. 2 times 3 is 9. 3 times 2 is 6. 2 times 3 is also 6. 6 plus 6 is 12. 12 minus 12 is 0. So it satisfies second equation too. Since this solution satisfies both equations, that means our answer is correct. There is no question of anybody deducting your points. Just make sure that some extra thing is or may or may not have been asked. So if you just leave it here, remember in this question, something extra was asked, that shading was asked and the intersection with x-axis was asked. So please read the question carefully and check whether anything extra besides solution and intersecting point has been asked. So solve the question accordingly. So the vertices of the shaded triangle are like 2, 3, 4, 0 and negative 1, 0. That's your final answer. Let's go to the fourth question, fourth chapter. Quadratic equation. We have seen what is quadratic expressions, quadratic equations in the second thing when we studied polynomials. Quadratic equations are come in the format ax square plus bx plus c equal to 0. Their solution is given by x equal to minus b plus or minus square root of b square minus 4ac upon 2a. That means quadratic equation gives you two solutions, one by the plus sign, one by the minus sign. So let's write them separately. Once I'm going to write them with the plus sign, once I'm going to write them with the minus sign. Now that is the reason. The first part is same in both situations. What is different in these two solutions is immediately which is following within that square root sign. So nature of roots is primarily defined by the thing which is followed by that plus or minus sign and which is under the square root. So the discriminant, which is this b square minus 4ac. Remember what is the discrimination means? Like if you are giving different treatment to different people, that is called discrimination. So just like that in here the discrimination is created by the thing which is under the square root, which is b square minus 4ac. So if they ask you calculate the discriminant, calculate b square minus 4ac only. Or if they ask you what is the nature of roots, well, you don't have to compute everything, you just calculate b square minus 4ac. And let's see, there are three scenarios, three sub situations, and let's see what is the meaning of this one. If b square minus 4ac is greater than 0, that means there is something here. So ultimately after calculating square root, you will get something in this part. So minus b plus something will happen, minus b minus something will happen, and you will get two different roots. These are real because you can calculate the square root of positive things, absolutely no problem. So you will get real roots and you will get different or distinct roots. As opposed to that, if b square minus 4ac is 0, which is like under the square root, if it is 0, that means there is nothing here, means square root of 0 is 0. So minus b plus nothing and minus b minus nothing. So what will happen? You will get this root and this root exactly identical, because the thing which was supposed to create differentiation or discrimination, that discriminant itself was missing here. So that is the reason you will get like two equal roots. You will get real roots, yes, they will be real, you will be able to compute them, but there is not going to be any difference between these two roots, and they are going to be identical. So if b square minus 4 is equal to 0, you will get real but identical or same roots repeated twice. Same thing will be repeated again twice. Now in the last case, b square minus 4 is less than 0, that means under the square you have a negative number. Now you cannot calculate the square root of negative number unless you go into complex numbers, but we don't have them. So for the time being, we will assume that it is impossible to calculate the square root of negative number, and that's why you will get some imaginary thing and the roots will not be real. So in that case, they will not ask you to process further. If they ask you just nature of the roots, calculate what is under square root. You don't even have to calculate square root because they are not asking you the exact answer, they are asking you nature. So nature is defined by what is under the square root, and that's all. You have three scenarios and these are the three situations. Discriminant is b square minus 4ac. Now let's quickly see a question. Again, this is from 4 to 3, which is standard NCERT textbook. Find two numbers whose sum is 27 and product is 182. Here I suspect that this chapter is quadratic. So quadratic is created when you have x square. In order to create x square, something must be multiplied with something. So there will be two factors. So the question will be definitely involved product. Well, yes, there will be some, but the product part is absolutely necessary, because when you multiply, then only x minus something or x plus something will be multiplied by x minus something or x plus something, and you will get a quadratic equation. Let's see how that happens here. Let the numbers be x and 27 minus x. Well, x is because it's unknown. Why 27 minus x? Because their total is 27. So if one part is x, the second part is a remainder from 27. So it is going to be 27 minus x. Now the other condition is product is multiplication is 182. So I am going to write down their product. First number is x, second number is 27 minus x, their multiplication is 182. It's a matter of opening the brackets. X times 27 will be 27x, x times negative x will be negative x square, 182 as it is. Now in order to get a quadratic equation, remember the quadratic equation is in the form ax square plus bx plus c equal to 0. That means everything must be transferred to one side and the other side will be having absolutely nothing. That's why we have 0. So now 182 can be transferred here, absolutely no problem. But I prefer to transfer this minus x square because I don't like this minus sign. So let's keep 182 here and transfer minus x square on that side so that it will become positive. Positive coefficients are preferred, especially when it comes to x square coefficients. So let's transfer everything from the left hand side to the right hand side. That will mean on the left hand side there will be absolutely nothing. So it will have 0, 182 as it is, minus x square transferred to become x square, and 27x will become negative 27x. Now at this level you have two choices. You can use the quadratic equation what I have explained in the previous slide. Get the values of a, b, c coefficient, directly plug in, no need to worry about anything. This is the sure shot method, but computationally it will have more chances of making error. You will get answer, but there is a chance of making mistake. If you are not comfortable with factorization, remember you have two methods. One is by quadratic equation, one is by factorization. If you are not comfortable with factorization, go for quadratic equation. Just plug in the values, keep on calculating the expressions, simplify, 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 get the answer. That's a sure shot method. You don't have to think too much. Just plug and play. As opposed to that, if you want more intuitive or if you are generally comfortable with factorization, then you can go for factorization. Here I have just for the sake of this thing, 182 can be split as two things. One is negative 14 and another one is negative 13. Remember, you have to split in such a way that the product comes out to be the last term. Remember, there is nothing, so we don't have to worry about the product here. If there is nothing, then only concentrate on the last term. If there is something, then you have to multiply 182 and then that number. Luckily, there is nothing, so that's much simpler. 182 can be simplified or split as negative 14 and negative 13. Now, why I am splitting in this way? That their product is 182 and their addition, sum total, is equal to middle term. If you do this in this particular manner, then only you will get a repeated factor. If you don't take this precaution, you will get some random factors and you will not be able to take something common. Let's see what that means. The middle term negative 27x has to be split into two parts, negative 14x and negative 13x. From the first two part, x can be taken common, so x taken common, x minus 14 will remain, and from here you can take negative 13 common and then x minus 14 will be remaining. Now note that x minus 14 is the repeated factor that can be only written once, and whatever is left over can be transferred into a separate single bracket. So when the product of two terms is equal to 0, that means first term can be 0 or second term can be 0. On the extreme worst case, both term can be 0. So I am going to write x minus 14 equal to 0, which is the first term, and x minus 13 equal to 0. So we will get two answers, one is 14 and one is 13. Then if x is equal to 14, the second term will be 27 minus 14, which is 13. But then you will say, oh wait, there is another solution. Okay, you can take that solution also. If x is 13, then this will be 13 and this will be 27 minus 13. That would be 14. So one of the numbers is going to be 13. If this is 13, this will be 14. Or if this is 14, this is 13. So these numbers are 13 and 14. So that's the order is not really important here. So the two numbers which are asked in this question are 13 and 14. Again, this is a very good example because you can, whatever answer you have got, you can directly cross check and make sure that your answer is 100% clear. Before you come out of the exam, you are 100% positive that your solution is going to give you full marks. Let's cross check. What answer we got? One number is 13, one number is 14. Their sum is 27. Fantastic, absolutely no problem. And you can multiply them on a separate piece of paper. In fact, there is no need to do that because we split 182 as 14 and 13. So we know that their multiplication is 182. 2. So this question answer is 100% correct, and that should boost your confidence. Let's go to the next chapter, chapter 5, arithmetic progression. Arithmetic progressions, let's quickly see the terminology. A is the first term, L is the last term, D is the common difference, and N is the number of terms or the location or position of that particular term in that entire series or entire sequence. First of all, what is the meaning of arithmetic progression? Arithmetic progression is a sequence of number where the successive terms, the difference between successive terms is constant. We have two types of formula in this case. Nth term is denoted by an, a plus n minus 1 times b. This is obvious because a is the first term. If you are standing at the first term, which is a, and you want to reach to the nth term, you have to take n minus 1 steps or jumps, and each step or each jump is worth d. So starting from a, you have to take n minus 1 jumps, each worth of d. So n minus 1 times d will be added to a, and that's how you eventually land on an, which is the nth term. So this is the formula for finding out nth term. Another option is, another type of formula is to find sum up to nth term. Here you have to be very careful what is exactly asked in the question. If they ask you only one term, nth term, the term which is at the nth spot, then you will have to deal with this particular formula. But if they are asking the total of all the terms up to nth term, then you are actually gathering all the terms up to that location. So we have to consider the formula into this one. There are two formulas again in this one. Sn, which is sum up to nth term, is n by 2 twice of a n minus 1d. If you notice that I can take out of this 2a, 1a separate, and a plus n minus 1d is this one. So I can use that as a last term. Remember, 1a will still remain. So this formula and this formula is not really different. They are not like completely different formula. It depends upon what you know. If you know number of terms, first term and the difference, go for this one. If you know first term and last term, then you can go for this formula. So it really depends upon what you know and what you don't know. Another option is get the last term using this formula, and then because some people prefer this formula because there are only a plus l, the bracket is so simple, they calculate this separately and then they plug in. It's not absolutely necessary. You can directly plug in into this formula. That will save some time, but it's up to you. My point is, it really depends upon if you know the last term, go for the simplified formula. If you don't know the last term, then go for this formula directly. Now let's see a quick question. 523. How many 3-digit numbers are divisible by 7? This doesn't look like arithmetic progression formula, but here we are talking about some numbers which are divisible by 7. If you see a standard table of any number, or let's say 7, then all the numbers will be equispaced. The distance between the successive terms will be 7. So this is a question of arithmetic progression because the numbers which we are talking about are equispaced. The distance between successive terms is actually 7, and we are talking about 3-digit numbers. So how should we solve this formula problem? 3-digit numbers are all the numbers starting from 100 till 999. Now is the first number divisible by 7? No. So we have to ultimately create a spectrum of numbers, a sequence of numbers, and that number, should it start from 0? No. Should it start from 100? No. Because the first number which is divisible, first 3-digit number which is divisible by 7 is 105. So our sequence is going to start, our progression is going to start from 105. And the last number which is divisible by 7 is not 999. We have to go a couple of steps backwards. And the last number which is divisible by 7, a 3-digit number, which is 999. So our arithmetic progression will be starting from 105, ending with 994. Now they are not asking you the total, they are asking how many terms are there. So we have to find out the number, the location of the 994 in this entire series. So let's see what we know about this one. The first term, this is the formula we are going to use because we are not interested in the total, we are interested into the location of the nth term or the last term. Here first term is 105, common difference because these are equispace, they are divisible by 7. Quick check, if you are finding out numbers divisible by 7, then the spacing will be 7 and this common difference will come out to be 7. Let's say if they change this question, divisible by 10, well then the common difference will automatically come 10. If this number is, we are interested in divisible by 6, this will become 6. Now, an is nth term, is the last term in this case, 994. So it's just a matter of substitution. 994 equal to 105 first term, n minus 1 times 7. Remember, n is the unknown because we want to know nth term is 994. What is the number of this 994 if everything is arranged in the ascending order, which is right now. So let's expand the bracket. 7 times n minus 1 will become 7n minus 7. 105 minus 7 will become 98. 98 can be transferred to the other side. It will become 896 equal to 7n. Let's divide both sides by 7 and your answer will come out to be 128. So what is the meaning of this answer? There are 128 terms in this entire sequence. If you start with 105 and if you end with 994 and if the numbers are having a spacing or a gap of 7, then there are 128 numbers. So there are 128 three-digit numbers that are divisible by 7. That's your final answer. Let's talk about triangle. This line is extra. In 9th grade we studied about congruence. Congruence means exactly identical, as there are a couple of tests for congruency. SSS, side side side, SAS, side angle side, AAS, angle angle side. We can use ASA also, absolutely no problem. However, thing to be very clear in this case, there is no AAA. Here A stands for angle, A stands for side, S stands for side, A stands for angle. So there is no triple A here. There is no such thing called angle, angle, angle. If three angles are matching with three angles, there is no guarantee that the two things are equal. In fact, that will go into the similarity which we are studying in 10th grade. So just before that, I want to give a quick review. And in addition, we have RHS, which is in a right angle triangle. If hypotenuse and side of one thing is equal to hypotenuse and side of the other triangle, then these two triangles are congruent. So congruent means exactly identical. You can place them on top of each other and there will be complete overlap, no gap, no excess. As opposed to that, what we are seeing in 10th grade is more similarity. Similarity means they are in proportion, they are like, for example, my photo and me are similar. I mean, if you post my photo on me, it will not precisely match with my dimensions, obviously. So these are called similar things. In similarity, again we have basic test, but the context is slightly different. If it comes to side, the sides have to be proportional. So that means the ratio of first side with first side equal to ratio of second side with second side, which is equal to ratio of third side with the third side of the second triangle. So when it comes to sides, the sides have to be in proportion. Remember, now we are talking about similarity. So SSS in similarity is slightly different in SSS. Here also they talk about side, 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 but the context in which side is described is completely different. Side has to be in proportion. In congruency, side has to be exactly identical, matching. That's it. However, if you have angle, angle has to be matching in similarity. So remember, all three angles together is 180 degrees. So technically we don't need all three angles matching with all three angles. If two angles are matching with two angles, then third angle will automatically 180 minus the sum of first two angles. So that will be guaranteed to match anyway. So even if two angles are matching with two angles, that should be sufficient for similarity. Now what if you have a mixture, side, angle, side? That means one side is proportional to the third side, and or I should say second side, and the included angle is same. So when it comes to angle, angle has to be same, but side has to be proportion. That's the difference between congruency and similarity. You have to be a little bit careful here. People think that this SAS and this SAS is same. Well, the meaning is same, but the context is different. Sides have to be proportionate, angles same, identical. Let's quickly revise what is necessary for triangles. We have seen Pythagoras is applied for right angle triangle. We have the sum of squares of two individual sides that make 90 degrees equal to square of the hypotenuse. So you can write a square plus b square plus c square. Quick tip, if you know the basic Pythagorean triplet like 3, 4, 5, 5, 12, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25. What numbers I'm talking randomly? Well, these are the Pythagoras triplets. Do you really have to know them? Not necessarily, but if you know them, then you can sense that a given triangle is right angle right in the beginning, and you will be in a better position to calculate area and all that stuff. So at least some preliminary triplets, 3, 4, 5, because 3 square plus 4 square equal to 5 square, such that then multiple of that, 6, 8, 12 is also Pythagorean. 5, 12, 13, because 5 square is 25, 12 square is 144, your addition is 169, which is 13 square. So 5, 12, 13 is also Pythagoras triplet. Make a list of first 4 or 5 Pythagoras triplet. Just remember them. If you see them, that will be helpful one way or the other. Also, it will be a beneficial idea to know the squares, at least up to 20 or 30. I mean, I recommend 30. So square of 22 is 484, square of 27 is 729, square of 18 is 324. I can just make random numbers, and if you know their squares, it will help you, because there is another chapter coming up, Heron's formula, in chapter 10. There we calculate the square root. If you know the squares, then you can calculate the square roots easily. You can factorize things effectively. So a suggestion, if you can, yes, definitely do that. Area of a triangle. Okay, actually the animation is weird. Area of the triangle is half times bh, base times height, and we also saw a thing. I have tried to create a statement which is not exactly matching with the NCERT statement, but for quick understanding, if you have a triangle and if you have a line joining the 2 points DE. Now, if parallel, then proportional. What is the meaning of this thing? If DE is parallel to the base BC, then it creates 2 proportional triangle or similar triangles. AD and DB will be proportion, AE and EC will be in proportion. So if parallel, then proportional. That's one way. So that means AD upon DB is equal to AE upon EC, AD upon DB is equal to AE upon EC. That will happen if this is parallel to this one. Or the other way around is also possible. If proportional, then parallel. If you know that this is proportional, then you can say that, oh, this line is going to be parallel to the base anyway. So remember, if parallel, then proportional, or vice versa. If proportional, then parallel. That's the way you can use that in similarity. This will be used. A special case of this one is the midpoint theorem. Midpoint theorem is like if you are joining midpoint to midpoint, then this is definitely proportional, and then is it definitely parallel. Okay, so that was about triangles. Let's see a quick this thing. This is the symbol for congruency. This is the symbol for similarity. You will be surprised to see not many people still know this one. It's okay. This is a revision class anyway. I will take care of it. This is again from the standard textbook. ABE and ACD are given congruent, so that means they are exactly identical. Let's try to show them in color. This is already given as a part of the question, so that means this triangle and this triangle are exactly identical. We can use CPCT, which is corresponding parts of congruent triangles, and I can say that AE, which is the small on the right, is equal to AD, which is small on the left. CPCT stands for corresponding parts of congruent triangles. Similarly, I can say AB, which is the bigger side on the left, equal to bigger side on the right. CPCT. We can take the ratio, and now I can slide these things. AE and AD, I can just interchange. They are identical anyway. So now AD upon AB, AD small upon big on the left hand side is small upon big on the right side. So I will keep this. I will need that for showing the congruency. Now let's get rid of the shade. Now they are talking about these 2 triangles. So let's try to shade them. AD is the green triangle, smaller one, and ABC is the blue triangle, bigger one. Now what is there? The two sides are in proportion with the two sides. So side is already taken care of, and there is one angle A which is common between these two triangles. So now we have two sides which are in proportion, one angle which is exactly identical. So we can go ahead and use SAS criteria, side angle side. Two sides are in proportion, one angle is exactly matching. So now we can say SAS criteria gives these two triangles are similar. Okay. 7th chapter, coordinate geometry. Well, I am assuming that you know the basic stuff about x-axis, y-axis, origin, how to plot a graph that we have seen in this chapter 3. You know what is the meaning of quadrant. Quadrant is the subdivision of the space created by the two axes. So we have quadrant 1, quadrant 2, quadrant 3 and quadrant 4 taken in anti-clockwise or counterclockwise manner. Okay. So here we have two things. One is section formula, and section formula is, let's say we have two points connected giving a line, and let's assume that their coordinates are x1, y1 and x2, y2. So section formula tells you what will be the coordinates of the point intermediate in between. It is also called internal division because there is something called external division also, which you do not have fortunately. But this is actually internal division. So a point somewhere in between the original two points, in what proportion it divides. So they can give you proportion, and this proportion will be m is to n. So 2 is to 1, 2 is to 3 or 5 is to 1. They can give you different values for m and n. M and n are just numbers, plain integers. So the coordinates, I should have written that x dash and y dash. X dash is equal to mx2. Okay, remember it's a cross product, m x2 n x1. So many people they do mistake. First one doesn't go with first one. First one goes to the second one. It's a cross multiplication. M times x2 n times x1 divided by m plus n. For y we have to repeat the same procedure. Instead of x coordinate, now I have to take y coordinates. That is one thing, is section formula. Section formula, m and n can be anything. So it doesn't, depending upon if m is bigger, the p point will be pushed towards the second point. If n is bigger, p point will be pushed towards the first point. So it depends upon the relative strength of m and n. What if they are equal? M and n are identical. Well, in that case, it is like 1:1. So in that case, we will get midpoint formula. Midpoint formula is a special case of section formula. Section formula, you talk about generic m and n. In midpoint formula, you talk about 1:1. Because it's 1:1, their relative strength is identical. This point will neither be pushed towards x toward the first point, nor will be pushed towards the second point. It will be exactly in the middle, hence the name midpoint formula. So let's draw this diagram again, but now this time this will be exactly in the middle. So the relative strength of the distances will be 1:1. In that case, you can substitute m equal to 1, n equal to 1. So this is like x2 plus x and 1 plus 1 will be 2. So the midpoint formula is the simplified version of the section formula, where m is 1 and n is equal to 1. So now the midpoint coordinates will be simply average of x coordinates comma average of y coordinates, as simple as that. So again, they can ask you reverse question. For example, here m and n is known and you calculated the unknown coordinate p x y or x dash y dash. Sometimes they will give you the coordinate and they will ask you in what proportion you are going to divide this thing. So there, instead of taking m is to 1, m is to n, a quick tip is, instead of having two variables m and n, take k and 1. Those who have studied very well, they exactly know what I am talking about. You can still solve with m and n. What I am talking about here, if type 1 problems are m and n is given, the point is asked, the coordinates of the points is asked. Now I am talking about the reverse type. The reverse type means the coordinate is given and now they are asking for m and n. Well, we don't know m, we don't know n, so there will be two unknowns. Instead of that, the standard practice will be take k and 1. So k is to 1. If k comes out to be fraction, such as 2/7, then it is 2:7. We can see, we can manipulate that fraction anyway. Let's take a quick find the ratio, and this is exactly what I'm talking about. they have given us two endpoints and they have given a midpoint. This is not necessarily midpoint, it is somewhere intermediate point, not necessarily halfway. So now we have minus 3 comma 10, 6 comma negative 8, and we are supposed to find out the relative strength of their distances. So now we don't know m is to n. So instead of taking m is to n, now let's assume that required ratio, call it as k is to 1. Why I am doing k is to 1? Because I don't like two unknowns m and n. So most likely this k will come out to be fraction, which is actually good because then we can spread it apart, make it even. Let's see at the end of the solution I will explain you. But k is to 1, actually that way we have only one unknown. Now so this k is like m and 1 is like n. So remember, in the m formula we are going to substitute k, in the n formula we are going to put 1. So 1 means like nothing, you don't have to write anything. Same thing we are going to do for this one also. So now remember, the first point is negative 3 comma 10. So x1 y1 is negative 3 comma 10. Second point is 6 comma negative 8. So x2 y2 is 6 comma negative 8. It's just a matter of substitution. K is unknown. So pxy is equal to negative 1 comma 6. So this is all together after calculation negative 1. This is all together after calculation 6. So we are going to say negative 1 is this part and 6 is this part. So we'll get two equations. Well, first try to solve this one and we'll get some value of k. We don't have to even, that's the beauty of like arranging k is to 1. So by solving just x or just y, you can get the answer. Now the answer came out to be fraction 2 by 7, which is weird because we were expecting integers. But remember, we have taken k is to 1. So this 2 by 7 is to 1. 2 upon 7 is to 1. Or we can multiply both sides by 7. So this is actually 2 is to 7. So the final answer is 2 is to 7. You can write 2/7 is to 1, but that's kind of weird. Remember, k was taken something out of our own necessity for simplicity purpose. Eventually we have to write a nice answer. So you can, even though technically you can write 2 divided by 7 is to 1, but I strongly recommend that write 2 is to 7 by like making the common denominator. If you want to check, it's not really necessary, but you can check from the second one, and here also the value comes out to be 2 by 7. If you are accurate, the value from the first and second expression should exactly match. And this second part is not absolutely necessary. If your calculations are correct, if you are confident, if you don't have time in the exam, don't do the second part, just manually plug in and check whether they is equal, or just assume that you are okay. But if you want to be 100% positive, and if you have some spare couple of seconds to spare, you can do this part. If both numbers come out to be correct, then your answer is obviously correct. So this is your answer. 2 by 7 is to 1, or just take this 7 on the other side, 2 is to 7. So the point negative 1 comma 6 divides these two endpoints in the ratio 2 is to 7. That's your final answer. Trigonometry, very important part. We are going to see there are two chapters for trigonometry. One is the trigonometric identities, and the second one is the application of trigonometry. So let's see. One part is trigonometry is like they will introduce what's the necessity of the trigonometry. Trigonometry was created for measuring distances and heights. Say for example, height of the tree, directly I can climb on the tree, which is risky and not going to be accurate, but I can use trigonometry and find out the distances and the heights of the towers and trees and all those things. So that will come in chapter 9, but first we need to understand what are the trigonometry ratios. If you have right angle triangle, right now trigonometry is applicable for right angle triangle at this level, even though in real life you can use it for any angle. In a right angle triangle, the longest side opposite to 90 degrees is always hypotenuse. So let's assume an angle theta. This theta, for this theta, this is opposite and the last side is adjacent. So hypotenuse is always constant. For this angle, this is opposite and this is adjacent. But if you are talking about this angle, then this is opposite and this is adjacent. So it depends upon Opposite and adjacent depends upon which angle you are considering, so you have to be a little bit careful. Hypotenuse, you can just blindly say the longest side is hypotenuse, right, opposite to 90 degrees. So you have to be careful. Most of the times you get angles with reference to ground or base, so that's fine. So now sin theta is opposite over hypotenuse. Some people have different way of remembering this one, PB, PPC, something like that. But sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. Now we have three reciprocal ratios. So originally three ratios are sin theta, cos theta and tan theta. On top of that we have three reciprocal ratios. Cosec theta is 1 over sin theta. Now many people get confused here. They think like, oh, it's cosec, so it must be 1 over cos. No, it's actually other way around. Cosec theta is 1 over sin theta. Okay, so if you think about this cos, no, don't do it. It's actually the other way around. And sec theta, well, many people they think that, oh, it is s, so it must be like 1 over s sine. Again, completely wrong. It's other way around. Sec theta is 1 over cos theta. Cot theta and tan theta are easy to remember because this is tangent and this is cotangent. So their names are related, so they are reciprocal of each other. That way you can remember that one. So we have altogether 6 trigonometric ratios. Now we have some trigonometric identities. Sin square theta plus cos square theta equal to 1. That is true. Sin, well, we will see the restriction on sin and theta, cosine theta value. 1 plus tan square theta equal to sec square theta. 1 plus cot square theta is equal to cosec square theta. So these are the basic trigonometric ratios we have. We have one more relation which I have not written. I have written in the table. Tan theta is sin upon cos. So sin theta upon cos theta is equal to tan theta. Now there is a table, and many people remember this table. If you are not comfortable with this table, ideally you should memorize it. If you are still not comfortable with this table, I will show you some trick right now. And as soon as you get the question paper, or at the end of the answer paper, you can make a quick table. Remember, you can use some of this space for the rough calculation. Don't write it on the question paper, that may not be illegal. Write it on the answer paper at the end. You make a quick table so that before you forget, make the table by yourself during the exam, obviously. Theta can be from 0 degrees, 30 degrees, 45, 60, 90 degrees. Sin theta are these values. Sin theta increases from 0 to 1, cos theta decreases, and tan, well, I don't remember tan values. I can generate tan value from sin divided by cos. One way to remember is this thing: whatever is sin of 0 becomes cos of 90. So whatever happens on one end for sin, it happens for cos on the other end, and this is true. Whatever happens for sin at one end, the sin of 90 is 1. It happens for the cos for the other end, cos of 0 equal to 1. Similarly, this 45-degree line acts like a mirror line. So whatever happens on one side, exactly same thing happens for the other trigonometric ratio on the other side. So sin of 60 will be exactly matching with cos of 30, and sin of 30 will be exactly matching with cos of 60. And for 45, sin, cosine both are identical, 1 over root 2, 1 over root 2. They are same. Now, tan is basically nothing but ratio of sine and cosine. So that will be 1 by root 2 divided by 1 by root 2. That's 1. So I can extend this concept. 0 divided by 1 is equal to 0. 1 by 2 divided by root 3 by 2. Well, by 2 by 2 will get cancelled. 1 over root 3. These are identical. Their ratio will be 1. Again, by 2 by 2 will get cancelled. Root 3 by 1, which is root 3, and 1 divided by 0 is basically infinity. So tan value you can create on the fly without remembering. If your sine cosines are identical, and that too only you have to remember one side. For 45 both are equal, because it doesn't matter whether you consider this angle, that angle. Whatever happens on one side for one trigonometric ratio, exactly same thing happens. So treat this 45-degree line as a mirror line and create a diagonal relation, something like that. Sin theta always is less than 1. Sin theta cannot exceed 1. It can be 1 in the extreme case, which is 90 degrees, but it cannot be 1.1. Similarly, cos theta also cannot be greater. Now you are dealing with only positive values. Sin theta, cos theta can be negative, but for you only positive values are okay. So in your case, it will be between 0 and 1, extreme values included. Also sec theta, because it's a reciprocal, sec theta can never come below 1, because the reciprocal of number smaller than 1 will be always greater than 1. Similarly, cosec theta cannot come below 1. So sin theta, cos theta cannot go above 1. sec theta, cosec theta, since they are reciprocal ratios, they cannot come below 1. And tan theta can be anything. Tan theta doesn't have any restriction. Let's see a quick example. Now, they will give you some relation and they will ask you to find out missing trigonometric ratio. As long as you can create a hypothetical triangle satisfying the given ratio, you should be fine. Let's see what I mean. Here they have given 3 cot A equal to 4. So, cot of A is equal to 4 by 3. So, cot I am not still comfortable with it. I am more comfortable with sine, cosine and tan. So, I will go for reciprocal ratio. Cot reciprocal is tan. So, instead of 4 by 3 it will become 3 by 4. So, if I know tan, which is 3 by 4, can I find out at least sine and cosine? The answer is yes. You have to create a hypothetical triangle. Remember, tan is what? Opposite over adjacent. So, you have to create a triangle such that opposite is 3 and adjacent is 4. So, let us do that one. I create a hypothetical right angle triangle and consider this angle A. Remember, opposite has to be 3. So, I will mark this as 3, which is opposite, and adjacent has to be 4, which I will mark as 4. Now, if it is 3 and 4, the diagonal will be, hypotenuse will come out to be 3 square plus 4 square, and under square root that will be root 25, which is 5. Remember, we are using Pythagoras theorem. So, now sine A is equal to opposite over hypotenuse 3 by 5. Cosine A is adjacent over hypotenuse, which is 4 by 5. Now, we know sine, cosine and tangent. Well, it's a matter of substitution. Let's take LHS side. LHS is 1 minus tan square A upon 1 plus tan square A. Now, we substitute the value of tan square A, which is 3 by 4. Take the square. So, it will be 1 minus 9 16th and 1 plus 9 16th. Let's make common denominator. 16 minus 1 divided by 9, which is 7 by 16. 16 plus 9 divided by 16, which is 24. By 16 by 16 will be cancelled. So, answer will be 7 by 25. So, this is the answer simplification for left hand side. Let's do that for right hand side. Cos square A minus sin square A. Cos A I have already calculated 4 by 5. Sin A I have calculated as 3 by 5. So, let's square them, and luckily the denominator is identical. We don't have to do the common denominator stuff. 16 minus 9 is 7. 7 divided by 25. So, this precisely matching this one. LHS equal to RHS. Boom. Our answer is solved. Again, this is not a tricky problem. When you come across a trigonometric ratio and you are stuck and you want to calculate the remaining trigonometric ratio, a simplest way is to create a hypothetical triangle such that the original condition is matching. So, tan A was opposite or adjacent. So, I will create a triangle such that opposite is 3 and adjacent is 4. So, once you create the triangle, the missing side can be calculated using Pythagoras, and that should give us the 3 trigonometric ratio. Once you know the value of trigonometric ratio, boom, it's like the question of the substitution. LHS calculate separately, RHS calculate separately. They will come out to be equal. If they come out to be equal, then there is no question of like examiner cutting your marks, and you are 100% positive you are going to get full marks. So, my point is, as long as you are comfortable with the fundamental things, even before you come out of the exam, you should know that 80% of the answers are fully right, and only where you require some computation such as Heron's formula, there you have to calculate square root and all that stuff, or some LHS, RHS stuff which we have seen in the first chapter. There physically you have to multiply numbers, and there is a chance that you making like silly mistake or all these things. Okay, now let's go for the applications of trigonometry. If your chapter 8 is very well, then chapter 9 should be application. It's just a question of applying those things for real life scenarios. Now, this chapter is, many people they don't like it. It's word problems. So, the majority part of it is just to get the diagram straight. If you can understand a question and draw a diagram, interpret it very well, you have won half of the battle right there. Couple of things I would like to mention. Let's say there is a person here. This is called line of sight. Now, line of sight is, as the name suggests, it starts from the eye. So, if the height of the person is given, then we have to subtract from the ground. If nothing is mentioned about the height of the person, we assume that line of sight is same as the ground level. So, you have to be careful. Most of the times they don't care about the height of the person, but I have seen 1 or 2 problems. There are a couple of problems in the NCERT textbook where the height of the person is given. So, you cannot take ground level, you have to subtract this. Eye is that much distance away from the ground, above the ground. So, line of sight is the horizontal line originating from his eyesight. Subtract height is mentioned, otherwise assume at the ground level. Now, if the person is raising his eyesight level, then it is angle of elevation. On the other hand, if he is standing on the top of the tower or top of the mountain, lighthouse and all those things, then he may be looking down. So, in that case, angle of depression. So, angle of elevation and angle of depression are two sides of the same coin. It depends upon like how your eyesight level is modified such that your new eyesight level, whatever angle is making with the previous eyesight level, that tells you whether it is angle of elevation or angle of depression, as simple as that. But you have to be careful. Again, if you draw the diagram very carefully, then 50% of the battle is won right there. Let's take one of the question from the point of the ground. The angle of elevation, that's a keyword, at the bottom and the top of the transmission tower. Let's try to draw a quick diagram. Let's see, there is a transmission tower fixed at the top of a 20-meter high building. So, there is a building and on top of that there is a transmission tower. So, a person is standing on the ground from a point on the ground. So, person is here and he is looking at the bottom of the transmission tower, top of the transmission. Now, bottom of the transmission tower is like top of the building. So, bottom of the transmission tower, top of the transmission tower. So, this is the transmission tower and this is the building, and the transmission tower is on top of the building. So, okay. So, I have been given two angles. Now, a majority of the problems, I predict that a majority of the problems will be from this category. This is why I have chosen this problem. It requires two triangles, two unknowns, solving them, boom, as simple as that. You have to create two equations, two scenarios, so you have to consider two triangles. Only care has to be taken. Remember, trigonometry is defined for you only for right angle triangle. So, the two triangles you are going to consider must be right angle triangle. So, I cannot consider this smaller triangle because it is not right angle triangle. I will consider this smaller right angle triangle and then I will go for the bigger right angle triangle. Remember, it must be a right angle triangle. That's a keyword, because if I select this triangle, it looks small, simple, but what's the use of it? I cannot create a trigonometric relation out of the sides, so it's kind of useless. So, I will take this triangle, smaller, right angle triangle, and I will take the big triangle, again right angle triangle. So, now this is the building, this is the tower. The two angles given are 45 degrees. So, the smaller angle is 45 degrees, bigger angle is 60 degrees, and the height is 20, and tower height we don't know. So, we are going to do this. Now, we are going to consider a smaller triangle. For smaller triangle, and this 45 degrees, this is opposite and this is adjacent. Most of the times you will get tangent ratio, because hypotenuse is something not what you can measure directly. You can measure the ground distance and you are interested in vertical tower distances or building distances. So, majority of the time it will be tangent ratio, majority of the time, except if you are flying a kite, then the thread of the kite will be diagonal. Or if a plane is flying, a plane flies along the, plane is taking off or landing, then it travels along this hypotenuse. These are very specific scenarios. At that time only you will involve hypotenuse. Most of the times hypotenuse it does not get involved because it's like totally in air, you cannot directly calculate it. It's opposite and adjacent, so mostly tangent ratio. Again, that's my prediction. So, for this 45 degree, opposite is 20, adjacent we don't know. So, tan 45 is we know from the standard table, that's 1. So, opposite is 20, adjacent is as it is, we don't know. So, adjacent comes out to be 20. But this is not what we want. This is what we will use when we try to analyze the second triangle. So, this is the connection or the connecting point, the connecting parameter between the first triangle and second triangle. What is second triangle? We have not considered it so far. So, first triangle was the smaller triangle. My suggestion is always go for the triangle where you know majority of the stuff, or get something from the first triangle and utilize it for the second triangle. Okay. So, now I will get rid of the shade. Now, I will consider bigger triangle. For bigger triangle, now the angle has become 60 degrees. Now, the opposite is not just 20, opposite is this complete distance, which is 20 plus x. So, that would be tan 60 from the standard trigonometric ratio is root 3. Now, this opposite is 20 plus x, adjacent is still same. Adjacent is the common thing for a smaller triangle and bigger triangle. That's the reason why we calculated it first, so that it could be utilized in the analysis of the bigger triangle. So that you can see this 20 I have got it from here. So that was useful. Even though technically it was not asked, that will help me in solving the second triangle. So 20 plus x equal to 20 root 3. Now 20 will be taken on this side, 20 and then root 3 minus 1. Now you can leave your answer as it is, absolutely no problem, unless they have given the value of root 3, which is 1.73 approximately. Then you can leave the answer right there if root 3 is not given. That's your final answer in meters. That's it. That's the end of the solution. But let's say here somewhere if they have mentioned take root 3 equal to 1.73, then you have to do one step further, substitute the value of root 3 as 1.732 minus 1 and then multiply manually by 20. You should be comfortable with multiplying a decimal number with ordinary integer and vice versa, or two decimal numbers, and the final answer will come out to be 14.64. As far as circles are considered, circles are let's see basic terminology, get this out of our way. Circle, we have this chord, and this is minor side and this is major side. You can think about like diameter is the longest chord, the maximum chord that can happen is like or diameter is the chord which happens to pass through the center. Half of the diameter is radius, this is circumference. Basic formula, circumference is 2 pi r, area of the square is pi r square, and so on. We will revise this in chapter 12, I think, when we talk about like surface volume, surface area and volumes of solids. One thing which we should remember in case of circles, a chord, whatever angle it subtends at the center, let's say it is 2 theta, then it subtends the same chord for the same circle. It subtends half of that at any point on the circumference of the same side. So if this is 2 theta, then as long as this point on the same side of the same circle on the circumference, then this will be half of this one angle. So this angle is half, this angle is twice. So you can remember that. Let's see a quick question. Tangent PQ at the same point PQ on the circle radius r 5 cm meets a line through center O. Let's draw a quick diagram. Let's say this is the circle, this is the tangent. Tangent meets the circle only at one point. It never cuts it into like multiple points. Neither it leaves a gap. So tangent is a special line which will touch the circle only at one point. Now you know that the line joining the center and the tangent point of tangency is perpendicular to the tangent. So you can say that this connection to the center from the point of tangency P is perpendicular to the original tangent. This is true for circle anywhere. Then now they have said that OQ is 12 centimeters, center to the point somewhere on the tangent outside the circle. So now we are supposed to find out PQ. Remember, this is the Pythagoras theorem. Right angle triangle, we can use various Pythagoras theorem. This is radius phi, this is 12, so we can calculate phi square plus QP square or PQ square is equal to 12 square. So 25 plus PQ square is equal to 144. Let's take phi square on the other side. 144 minus 25, that comes out to be 119. So remember, this is PQ square. So they can give you, just to confuse you, both answers, 119 and root of 119. People take as it is, that's wrong. You have to take square root of the both sides. So PQ is square root of 119 centimeter, and that's going to be your final answer. You can have some multiple choice questions, short answers, fill in the blanks, something like that from such chapters. I'm trying to mix and match these things so that difficulty level is balanced. Area related to circle, very simple. Full area is pi r square. Then a fraction of the circle is, well, it depends upon the angle. Remember, for a circle, the complete angle is 360 degrees. So if 360 degree gives you pi r square, theta will give you proportionate. So theta divided by 360, whatever is that fraction of the full circle, that is what we are going to get angle. So think about like this is the slice of pizza and this is the complete pizza. So if you take a slice of pizza, how much area you are going to remove? So that will be proportionate to angle. Here the complete angle is 360. Here the angle is just theta. So if this theta is half, you will get half area. If theta is 1, theta is 1/4, you will get 1/4 area, and so on. So it depends upon the fraction of theta related to 360. So that's why the area is 360, theta divided by 360 into pi r square. Here theta is measured in degrees. Now we can have one more thing. If the area is asked, then this is sector, as opposed to that if this particular thing is asked, then this is arc. So you have to be careful. Are they asking for the area which is covered, or are they asking you the fraction of the wire or fraction of the fence? Then you have to take about the only one dimensional object, curved line, which is this is arc and this is sector. So again, it's the same logic. It depends upon the angle theta. If you have complete 360, then you get a full circumference, which is 2 pi r. So you will get like a proportionate depending upon the value of theta. So theta divided by 360, that's a ratio of full circle. So partial circle is theta divided by 360 degree of full circle. Again, partial circle is equal to, partial circle area is equal to theta divided by 360 full circle area. So that's the logic, and I think that will help you remembering it even in a better way. Let's see surface area and volume. We are talking like a couple of objects here, combinational objects, and this basically you had did in the 9th grade. 10th grade is simply just like attaching different objects to different objects. So for example, cone is attached to hemisphere and cone is placed on the top of cylinder, like that. So as long as you are okay with the basic solids, there are 3 solids which are talking about. For cone, cylinder and sphere. Cone volume is 1/3 of the cylinder, which is 1/3 of pi r square h. In fact, we can put like same height and same base is there. You can put 3 cones inside the cylinder after melting, obviously. So cylinder is full pi r square h and cone is 1/3 pi r square h. Sphere volume is 4/3 pi r cube. Here the units will be cube, unit cube. So it will be millimeter cube, centimeter cube or meter cube. As opposed to that, if they ask you surface area, which is pi r, L is the slant height, this height. For cylinder it is 2 pi r h, which is circumference times height. Basically it's like a rectangle when you open it, and sphere is 4 pi r square. These are the formula you should remember. There are only 3 solids what we are talking about, and the complete surface area if they are talking about total surface area, or TSA in short. Then you have to add the flat surface also. So here is only one flat surface, here you have 2 flat surfaces, and there is no question of flat surface in sphere. So in sphere they cannot ask you total surface area. Whatever surface area you have here, that itself is total surface area. However, for cone you have to add pi r is the curved surface area and the base of the area is circle, because pi r square. So if you added that to the CSA, which is curved surface area, you will get TSA, total surface area. Now for cylinder we have 2 surfaces, so 2 pi r h you have to add twice of pi r square, because one circle is pi r square, so top and bottom. If they have mentioned that it is cylinder is open from the top, then instead of 2 pi r square you will take only pi r square. Sphere, occasionally they use hemisphere, which is half of the sphere. So in that case, hemisphere volume is 2/3 pi r square, which is half of 4/3, and surface area is 2 pi r square. So I have not added that as a separate solid. If you know the sphere volume and sphere surface area, just take half of that. Statistics, well, we have 3 things here: mean, median and mode. Let's see the meaning of them. Mean is simply average. If you collect everything, say for example, there were 5 tests conducted in my class, and the teacher decides to take average. So what she will do, he or she will simply add the total score and divide by 5. So it's like total divided by number of observations. Median is the middle value. So if you arrange everything in ascending or descending order, say for example in physical training class, your teacher arranges you in the school ground, mostly in the ascending order of the height. So if everybody is arranged in that manner, whoever is the middle person, whatever is the height of that person, that's your median value. Mode is the most frequent value. So if many people belong to the same height, then that will become most frequent value or mode. Now let's see different formula for mean. Direct mean method is simply you have to, sigma stands for summation, which is like total. Sigma, which is this particular weird looking symbol, that's like total, sigma. And fi, xi. Fi stands for frequency, xi means individual x, I means like individual value, like this one. So if x values are there occurring f times, which is the frequency, then you have to multiply that one, you have to make everything total, and remember divide by total number of observation, which is sigma fi. F stands for frequency, x bar stands for average, which is the mean. So this is the direct mean method. If you have one observation repeating f times, second observation repeating f times, and so on, mostly you will use direct method. Direct method has complications because sometimes bigger numbers are involved. You are not allowed to use calculator, there is a chance of making mistakes. So now there are two additional methods. One is assume mean method, where you assume certain mean and you keep it as a reference, and instead of adding all numbers from grassroots level, from wholesale level, you are only considering their deviations or their differences. So here A is the assumed mean and then D is the deviation or differences. So you will talk about like only the displacement or deviations from that assumed mean. And step deviation method, you found out that these deviations are multiples of something, you try to get rid of them by taking a common factor. To compensate for that, eventually you have to multiply by that h. So this formula and this formula is not really different. Instead, these deviations are multiples of something, so we take some common factor and we make it even simpler by reducing the number. But I have to add, I have to multiply them by whatever I have divided to make it simple to compensate for that. So these two formula are kind of similar, except this one involves division and multiplication to compensate for each other. Median has specific formula given. L is the lower of the class interval in which mean is supposed to be there. N by 2 is the half of the number of observation. CF stands for cumulative frequency. F is the frequency and H is the class interval. Mode, the formula given in the textbook is slightly different, but it is exactly identical. Trust me, they have written F1 and F1 as 2F1. Well, I prefer this way because we calculate the differences from the previous class interval and the next class interval. So this is the difference from the previous class interval, again previous class interval and next class interval. So if you calculate their relative strength, multiply that by the class interval, add that with the reference line, which is the lower of the class interval, that will give you more value. These three you have to remember. These are kind of complicated formula. If you understand the logic, there is a chance of remembering them without any mistake, but my suggestion is write them down like 10 times each just before the exam, that way we will never forget them. Let's solve a quick question. Length of 40 leaves, so total number of observation is 40, right there you can figure it out. Our measure correct to the nearest millimeter, data obtained is this one. Now one quick thing here, the data has to be continuous. This is taken from again standard NCERT textbook. The data has to be continuous. So first thing you should check whether is the data continuous. Here it is not. For example, this is 126, this is 127, there is a gap of 1 millimeter. So we have to stretch so that no class interval is like having a gap. So since the gap is 1 millimeter, 126 is the end point of the previous interval, 127 is the beginning of the next interval. So that 1 millimeter gap you have to cover, and this is true for any two subintervals. So we are going to split that into half and half, which is like 1 millimeter divided into two equal parts. That would be 1 by 2 half millimeter. So subtract half millimeter, add half millimeter, subtract half millimeter, add half millimeter, subtract half millimeter, add half millimeter, and so on. That way the data or the class intervals, I should say, will be continuous. If you do that, well, I'm going to do that as a separate column here. Cumulative frequency is, as the name suggests, it keeps on accumulating, hence the name cumulative frequency. So first take the first observation as it is, add the next observation 5, add next observation. So 3 as it is, 3 plus 5 is 8, 8 and 9 17, 17 and 12, it will be 29 here, 29 plus 5 is 34, 34 plus 4 is 38, 38 plus 2 is 40. Now How do you know that you are accurate? Because the last value must always match with the total number of observation. Because if everything accumulates, you are going to get everybody anyway. So how much is everybody? 40 leaves. So last observation will always match the total number of observations, or sigma fi. Now remember, I talked about the class interval stretching so that the gaps are not there. So now the continuous interval will be half less, half more, half less, half more, half less from the lower end and half more from the upper end, and so on. So if you do that, the class intervals will be now continuous. N equal to 40, that's the total number of observations. N by 2 equal to 20. So 20 lies here. So can we say which class interval our median is supposed to be there? Median is supposed to be there where 20th guy is supposed to be there. Now up to 17th guy are here, so that's not our median. 20th guy is between here, so in this class interval it will be there. So first we have to calculate in which class interval our median is supposed to be there, right? Remember, there are 12 people. We don't know their exact values, but they are somewhere in the middle of this. So our 20th guy is somewhere here. So now it's a question of plugging in the values. L value is the lower of the class interval. That's 144.5. Now people will make mistake, right? 145, that's wrong. Take 144.5. And then N by 2 is, well, we have just calculated as 20. F is the frequency of that class interval, which is 12. Cumulative frequency of the previous class interval, here people make mistake, is 17. And H is the width of the class interval, it's 9. So that would be sufficient to plug in the values. If you calculate this one, that will come out to 1/4 of the 9 has to be added to 144.5, and your final answer is going to be 146.75 millimeter. And that's going to be your final answer. Remember, this is the length of the leaves, so the unit will be millimeter. The probability chapter, well, there are a couple of things. Well, there are 3 things to be very precise. One is coin. Coin can be tossed once, coin can be tossed twice, or 2 coins can be tossed. It's the same thing. So if you toss one coin, they have 2 outcomes, heads and tail. H stands for heads, T stands for tails. 2 coins, we have 4 combinations: head, head, tail, tail, head, tail, and tail, head. In general, if you toss the coin n number of times, you get 2 raised to n. So if there are 3 coins or one single coin tossed 3 times, you will get 2 raised to 3, which is 8 combinations, which I have not shown. That's kind of rare. Second thing is like the die. A die is 6-sided, so you can have like any one of the 6 possible numbers starting from 1 all the way till 6. And the third one is card. Well, we are going to see cards in detail. There are 4 suits, which is we are going to see that in the next slide anyway. There are 13 cards in each suit, so there are altogether 4 times 13, which is 52 cards. Now probability of any event is favorable upon total. How many ways that thing can happen, as opposed to that how many ways altogether that thing can happen, whether it is likable, favorable or not. So that is the basic formula of probability. Probability always lies between 0 and 1. Extreme values are included. If the probability is 0, that is called impossible event. If the probability is 1, that is called sure event, definite event, or certain event. So tomorrow the sun will rise at the east, that's a sure event. Or you can consider like it will rain in the desert, that's kind of impossible event. Well, there's nothing impossible, but theoretically it's 0. So let's see a question involving cards. One card is drawn from a well shuffled, means mixed properly, from a deck, which is a collection of 52 cards. Find the probability of this thing. So let's quickly see the terminology of the cards. Cards come in 2 colors, red and black. Each color is further divided into 2 suits, heart and diamond. Black is also club and spade. Now many people, they might be familiar with the probability, but cards either they may not be playing or they may not be knowing these names in English. So it's a good time that they should know bare minimum knowledge about the cards. I don't want you to be like an expert player in the card, just know the basic terminology, that's all, for the sake of solving problems. I had difficulty when I was a student. So because I did not study them in English, each suit has 10 number cards. So number 1 card is also called ace. Then you have 2 of heart, 3 of heart, 4 of heart, and so on. This goes on up to number 10. At 10, the numbers stop, and then these are called number cards. So there are 10 cards in each suit. There are 4 suits, 2 suits from each color. So there are 2 colors, red and black, eventually a deck of 52 cards. After 10, what happens? Then you get face card. You have jack, joker, whatever you call it. Then queen and king, these are having faces printed on them. So that's why they are called face card. So you should not get confused about when they say face card, number card, and all those things, because that is mentioned here. So I don't want you to take any risk for that. Now, so for heart there are 13 cards. Then for diamond there are, I have taken the same symbol as what you see in the real life, so as to avoid confusion. Club is also 13 cards, and spade also 13 cards. So altogether we have 52 cards, 4 times 13. Now let's see the question. The question themselves not really difficult. Probability is in fact the easiest chapter if you know what you are doing. If you understand what they are asking, then it just there are no calculations involved. It's just like simple fraction simplification at the most. But you need to understand what they are asking. Here, king of red color. Now red color, and they want king. So how many red kings are there? Well, we have one king which is from the heart, and we have one king from the diamond. Both are actually red. So a king of red color is 2 ways we can get this thing out of 52. So because 2 things, there are 2 red kings out of 52. So on simplification it becomes 1 by 26. Second one is face card. Now face card, they haven't mentioned color, so it can be red face card or it can be black face card. It can be any of suit, that doesn't matter. They are not specific in that aspect. So face card, there are altogether 12 face card, 3 times 4. That will be on simplification 12 by 52 will be simplified as 3 upon 13. A red face card, red face card. So now we are talking about face card, but only within the red color. So that would be 6 cards out of 52. That on simplification it will be 3 upon 26. Next one is jack of hearts. Well, jack of hearts there is only 1, so I will write 1 upon 52. And last, a spade. Spade can be anything out of these 13. So there are 13 spades out of 52 cards, and that would be 13 out of 52. And the queen of diamonds will be, there is only one queen of diamonds. That's right here. So I will try to animate as much as possible so that you will understand what I am exactly doing. There is only one queen of diamonds out of 52 cards. So that will be 52. Okay, and I think that's all for the time being. I will try to put a cheat sheet in the description. Thank you very much for your patience, and hopefully you like this video. Like, subscribe, comment, and share with your friends. 2 things you are supposed to do: explore my channel. I have probably more than 140 videos which I have created for the solutions. They are very compact. That's one thing. And also visit vidyanti.com. It has AI generated notes. If you would like to see something more, or these videos are embedded right there also. So thank you very much. Have a wonderful